Hello and welcome. Tonight we're going to begin a quiet, quirky journey through the periodic table, a place you might remember as a colorful chart from school, but which is really a garden of characters, each with its own odd habits and charms. Don't worry, I'll try not to make it too fascinating. After all, this is bedtime, not chemistry class. Think of it more like wandering through a collection of old friends, some serious, some silly, all quietly shaping your world. Before we set off, take a moment to like the video and subscribe, but only if you truly enjoy these sleepy science journeys. And if you're still awake at the end, I'd love to know where you're listening from and what time it is there. It always helps me imagine these stories glowing softly in different corners of the night. Now, pull your blanket a little higher, let your shoulders soften, and let's begin not with a bang, but with the smallest whisper of an element. Hydrogen. Hydrogen is the first square in the periodic table, the simplest atom in existence. Just one proton, one electron, and if you're lucky, maybe a neutron tagging along. That's it, the absolute minimum recipe for an element. It is so simple you might expect it to be boring, but hydrogen is anything but. You drift now into the vastness of space. Stars shimmer around you, and you realize that nearly 3/4 of all the normal matter in the universe is hydrogen. Every twinkle you see is a ball of hydrogen, fusing in its core, turning into helium, lighting up the night. Without hydrogen, there would be no stars, no warmth, no light. And yet here on Earth, hydrogen often slips away. Being so light, its atoms can escape our atmosphere, drifting off into space. Earth couldn't hold on to it, so most of our hydrogen hides in compounds like water, that glass of water by your bedside. Two atoms of hydrogen cuddled around one atom of oxygen. H2O, the simplest and most famous arrangement in chemistry. But hydrogen has a mischievous side, too. It is flammable, eager to combine with oxygen in a bright burst of energy. It was hydrogen that filled the Hindenburg airship, and hydrogen that fuels rockets launching toward orbit. Light, abundant, and a little excitable, hydrogen is both friend and fire. Scientists still marvel at hydrogen's versatility. The same atom that floats balloons and stars also helps shape you. Every protein in your body, every strand of DNA, every drop of blood relies on hydrogen bonds, little attractions that hold molecules together, like tiny handshakes keeping the dance of life in step. Without hydrogen, biology would collapse into silence. You drift now into chemistry's past, where early scientists puzzled over hydrogen. Henry Cavendish in the 18th century called it inflammable air because it burned so easily. Later, Anton Lavoisier named it hydrogen, from the Greek hydro, water, and genes, creator, the maker, a name that turned out to be perfect. Hydrogen has quirks beyond names and history. Consider its isotope family. The common hydrogen atom has no neutron, just a proton and an electron. But sometimes it picks up a neutron, becoming deuterium, heavy hydrogen. Rare but stable, found in oceans as heavy water. Stranger still is tritium with 2 neutrons. It's radioactive, glowing faintly in the dark, used in old watch dials and in glowing exit signs. Hydrogen may be simple, but it loves to dabble in variety. And then there's hydrogen's behavior at extreme cold. At ordinary temperatures, it is a gas, invisible and weightless. But cool it enough, and it turns into a pale liquid, colder than anything you've ever touched. Cool it further, and it becomes a solid, its atoms barely moving as though asleep. Hydrogen, the restless wanderer, can also lie down and rest in crystalline stillness. Perhaps the most poetic truth about hydrogen is this: it is ancient. Nearly all of the hydrogen in your body, in the water you drink, in the molecules of your skin, was formed in the Big Bang 13.8 billion years ago. Every other element has been cooked in stars, forged in explosions, remade in cosmic furnaces. But hydrogen is original, primordial, the first breath of matter. So tonight, as you breathe in and out, know that the hydrogen in the water in your cells is older than stars, older than galaxies, older than Earth itself. You carry in you the universe's first whisper. And maybe that's the quirky part about hydrogen. It is both ordinary and cosmic, both lightweight and essential, both ancient and ever-renewed. It makes up balloons that squeak at birthday parties, fuels rockets, rustles in your DNA, and burns at the heart of stars. So rest in this thought. The simplest atom is also the most abundant, the lightest is also the oldest, the smallest is also the most essential. Hydrogen, the first step of the table, the first spark of chemistry, the first line of our bedtime poem. Hydrogen drifts gently into the background, light and restless, and now you slide softly into the next square of the periodic table, helium. If hydrogen is the fiery storyteller, helium is the quiet jester, always floating above the crowd, refusing to play by the usual rules. Imagine a balloon tugging gently at its string. Inside is helium, lighter than air, invisible, nearly impossible to pin down. A gas so aloof it slips through balloons one atom at a time, escaping into the sky. Children laugh as balloons rise, but helium doesn't laugh back. It's too busy drifting upward, away, out into the vastness. You drift now into space again. Most of the helium in the universe was forged not in stars, but in the Big Bang itself, alongside hydrogen. Together they form the cosmic majority, the two lightweights running the show. Helium, though, is more reserved. In stars, hydrogen fuses into helium, and the process lights the cosmos. Every sunrise is, in part, helium being born. But helium has a quirk, a delightful one. It refuses to freeze. Every other element, if you cool it enough, will eventually turn solid. Iron, oxygen, nitrogen, all surrender to the cold. But helium, no. Even at absolute zero, when motion itself is nearly gone, helium remains a liquid unless you press it with immense pressure. It simply refuses to lock into a crystal, a liquid dream, too slippery to hold still. And helium is not just liquid, it can become superfluid. At a few degrees above absolute zero, it flows without resistance. Pour it into a dish, and it climbs the walls, creeping upward in defiance of gravity. Stir it, and it swirls forever, never losing momentum. It's as if helium has read the rules of physics and politely declined. Scientists still wonder at helium's stubbornness. Why should one element refuse to behave, to crystallize, to freeze? Quantum mechanics explains it. Partly, helium atoms are too light, too jittery, too restless to settle down. But even with explanation, the behavior feels magical, a reminder that not everything follows common sense. Helium's quirks extend to the everyday, too. Inhaling it makes your voice squeak, a harmless prank at parties. Its sound waves travel faster in helium than in air, shifting the pitch of your voice upward, as though you've suddenly joined a choir of chipmunks. It is silly, fleeting, a scientific gag that never fails to raise a smile. And yet, helium is also deeply serious. It cools MRI machines in hospitals, keeping their superconducting magnets cold enough to work. It fills weather balloons, guiding instruments into the upper atmosphere. It whispers quietly in laboratories, a noble gas that refuses to bond or burn, too aloof for chemistry, too noble for entanglements. You drift now into helium's name. From Helios, the Greek word for sun, because helium was first discovered not on Earth, but in the solar spectrum. Astronomers in the 19th century saw an odd yellow line in sunlight, something new, unknown. They named it for the sun itself, decades before it was isolated on Earth. There is something gentle about that, isn't there? An element first known not by touch, but by light. A discovery made by looking at the sky, at a star, at the great lamp of our days. Helium announced itself in sunshine before we ever held it in our hands, and perhaps its most charming quirk is how it lingers in both extremes. Balloons at birthday parties and the furnaces of stars. Silly, squeaky, playful, yet also cosmic, fundamental, ancient. Helium, the element that won't freeze, won't bond, won't settle, always floating somewhere between laughter and starlight. So rest in this thought. Helium is a reminder that the universe has a sense of humor, that some things rise when expected to fall, flow when expected to freeze, whisper in sunshine and squeak in voices. Hydrogen began our story with a spark, helium follows with a smile, and together they fill the cosmos and your dreams tonight with lightness. Helium drifts upward, slipping away into silence, and now you settle softly into the third element of the table. Lithium. Light silvery and just a touch quirky, lithium is the quiet bridge between laughter and stability, the element that brings both sparks and calm. Picture a soft, silvery metal, so light you could almost mistake it for aluminum foil. Yet lithium is lighter still, so light it can float on oil, silvery droplets gliding like mercury on water. It doesn't shine forever, though exposed to air, it tarnishes, reacting gently with moisture, eager to combine. Lithium never lingers alone. It always wants to join in, to become part of something larger. You drift now into its name. Lithium comes from the Greek lithos, meaning stone. It was first found not in plants or gases, but in a mineral hidden inside rocks. A curious origin for such a lightweight element, one that hardly seems stony at all. Lithium has a fiery side. Drop it into water and it fizzes, releasing hydrogen gas in a sparkling display. Its cousins sodium and potassium are even more dramatic, but lithium has its own quiet mischief, fizzing and bubbling like a soda can freshly opened. In fireworks, lithium salts glow crimson, painting the sky in deep reds, a firework of chemistry hidden in stone. But lithium also has a gentler, steadier face. Inside your pocket or on your desk, lithium sits in batteries, the rechargeable kind that power phones, laptops, and electric cars. These tiny cells rely on lithium's lightness and eagerness to move, shuttling back and forth between electrodes, storing energy, releasing it, quietly powering modern life. The phone you may be listening on right now hums with lithium's help. And there is another role, even more personal. Lithium salts in small doses have long been used in medicine, easing the turbulence of bipolar disorder, smoothing the sharp edges of mood swings. The very same element that fizzes in water and paints fireworks red can also bring calm to restless minds. A paradox of chemistry, lithium sparks and lithium soothes. Scientists still wonder at the full range of lithium's powers. How can one light metal carry so many roles, reactive yet stabilizing, fiery yet calming, simple yet essential? It is the third element, small in size, yet vast in influence. You drift now into lithium's cosmic origins. Like hydrogen and helium, much of the lithium in the universe was forged in the first minutes after the Big Bang. But unlike its lighter siblings, lithium is rarer, easily destroyed in stellar furnaces. Stars burn hydrogen into helium, helium into heavier elements, but lithium struggles to survive, fragile in cosmic fire. And so on Earth, we treasure what little is found, mining it from salt flats, crystals, and brines. Perhaps there is something poetic in lithium's scarcity. The element that calms is also rare. The element that powers our modern lives hides in quiet pools beneath deserts, waiting patiently to be gathered. Not abundant like hydrogen, not aloof like helium, but present just enough to matter. You drift now into a desert salt flat where pools of brine shimmer under the sun. Beneath them lies lithium, waiting to be drawn out, purified, shaped into batteries, medicines, fireworks. A quiet resource shimmering in hidden corners of Earth, as though the planet has saved a little calm for us to find. So rest in this thought. Lithium is an element of balance, a silvery metal that sparks in water, yet steadies in medicine. A light atom born of the Big Bang, yet fragile in stars. A stone-born element, yet essential to the devices and minds of today. Hydrogen gave us beginnings, helium gave us laughter, and lithium now offers calm. The periodic table, it seems, is not only a chart of matter, but a gentle poem of moods. Lithium settles gently into its place, calm and balanced, and now you drift into the fourth square of the periodic table, carbon. If helium is playful and lithium is steady, carbon is the master of disguise, the element of masks and mirrors, endlessly reinventing itself. At first glance, carbon seems simple, just 6 protons, 6 neutrons, 6 electrons. Modest, really, but what it does with that simplicity is astonishing. Carbon bonds easily, and not just once or twice, but 4 times, forming chains, rings, lattices, and networks. It is chemistry's social butterfly, eager to connect, able to build nearly anything. You drift now into its most famous masks. In one form, carbon becomes diamond. Clear, brilliant, the hardest natural substance, forged under crushing pressure deep in the earth. In another form, it is graphite, soft, dark, slippery, leaving marks on paper, crumbling in pencils. The same element, the same atoms, arranged differently from sparkle to smudge, and carbon has more tricks. Stretch it into thin sheets, 1 atom thick, and you get graphene, a material so strong it could hold up an elephant with a hammock the size of a sheet of paper, and yet so thin it is nearly transparent. Roll those sheets into tubes, and you have carbon nanotubes, tiny cylinders stronger than steel and lighter than air. The same element, endlessly inventive, but carbon is not only found in laboratories and jewelry stores. It is in you. Every cell of your body, every strand of DNA, every protein and sugar, every thought sparked in your brain, all carbon. Without carbon's flexibility, life would collapse. It is the skeleton of molecules, the frame of biology, the element that writes the story of living things. Scientists still marvel at how carbon manages this. Out of the 118 known elements, only carbon can create such vast networks of molecules, branching endlessly into millions of combinations. This is why life, as we know it, is carbon-based. Silicon tried, oxygen helps, but carbon is the unrivaled builder, and carbon has its darker masks too. Coal, black and crumbling, once powered the world's factories and trains, filling skies with smoke. Carbon dioxide, invisible, slips from chimneys and exhaust pipes, warming the Earth's atmosphere. The same element that sustains life can also unsettle it, a reminder that even the most versatile actor has shadows in its script. You drift now into carbon's history. Ancient people knew it as charcoal, as soot, as graphite markings on cave walls. Diamonds dazzled crowns and jewelry long before their atomic structure was understood. Only in the 20th century did we begin to see carbon's full versatility in plastics, fibers, electronics, and nanomaterials. It has been here all along, quietly wearing its many masks, waiting for us to notice. And perhaps the quirkiest part is how close these masks sit to one another. A diamond and a lump of coal are not different in essence, only in arrangement. Shift the atoms, reorder the bonds, and one becomes the other. Wealth and soot, sparkle and dust, all one element, wearing different costumes. So rest now in this thought. Carbon is the shapeshifter of the periodic table, sparkling as a diamond, smudging as graphite, humming as graphene, living as you. It is the actor behind every scene, the ink in the story of life, the mask that hides and reveals all at once. Hydrogen gave us beginnings, helium gave us laughter, lithium gave us calm. Now carbon gives us variety, many faces, many forms, all quietly bound together by 6 small protons. Carbon fades softly into the background, shimmering between diamond and graphite, and now you drift toward the 5th square of the periodic table, nitrogen. If carbon is the busy builder, nitrogen is the quiet blanket, invisible, calming, yet with a surprisingly mischievous streak when stirred. Take a slow breath in. Most of what just entered your lungs wasn't oxygen at all, but nitrogen. Nearly 4/5 of Earth's atmosphere is nitrogen gas, a colorless, tasteless, odorless presence. It's so constant, you hardly notice it. Nitrogen surrounds you like a quilt, wrapping the planet in stillness. And yet, for all its abundance, nitrogen is oddly reluctant. Nitrogen atoms pair up into N2 molecules, bound together by one of the strongest chemical bonds in existence. They cling tightly, unwilling to separate. This stubbornness makes nitrogen simultaneously essential and elusive. Plants and animals need nitrogen for proteins and DNA, yet most can't use the nitrogen floating freely in the air. It must first be coaxed apart by bacteria, lightning, or factories before it joins the cycle of life. You drift now into a thunderstorm, lightning flashes, crackling through clouds. The energy is enough to snap apart nitrogen molecules, allowing them to form new compounds that fall to Earth with the rain. A natural fertilizer, written into the weather. Without storms, soil would slowly starve. Nitrogen has gentler quirks, too. Cool it down until it liquefies, and you get liquid nitrogen, a pale, boiling cold that looks like water but evaporates in ghostly white fog. Dip a flower into it, and the petals freeze instantly, shattering at a touch. Pour it on the floor, and it skitters about in droplets, too cold to settle. It is both playful and eerie, a reminder of extremes hidden in something we usually ignore. Scientists still wonder at nitrogen's balance of calm and chaos. On one hand, it is the quiet majority of the air, a silent background actor in every breath. On the other, it fuels explosives, TNT, nitroglycerin, ammonium nitrate, compounds that unleash tremendous energy when nitrogen's bonds finally break. From fertilizer to fireworks, nitrogen swings between nourishing and volatile, and then there is nitrogen in life itself. Your body is stitched together with it. Every amino acid, every strand of DNA, every neurotransmitter depends on nitrogen's bonds. It may hide in the air, reluctant to join in, but once it does, it becomes the scaffold of living systems. Without nitrogen, you could not think, could not move, could not dream. You drift now into the deep sea, where nitrogen behaves differently still. Divers who rise too quickly experience the bends, bubbles of nitrogen forming in their blood as pressure changes. A reminder that this invisible element, so constant and quiet above, can play tricks when conditions shift. And in the laboratory, nitrogen is often called inert, unwilling to react. But give it the right spark, the right partner, and it suddenly bursts with possibility. Like a shy guest who, once drawn into conversation, reveals endless stories. So rest in this thought. Nitrogen is the quiet blanket of the earth, unnoticed but essential, calm yet capable of drama. It cools flowers to shards, feeds soils with lightning, and builds the very code of life. Hydrogen gave us beginnings, helium gave us laughter, lithium gave us calm, carbon gave us masks. Now nitrogen gives us balance, silent most of the time, but vital in every breath, every cell, every storm. Nitrogen's quiet blanket settles back into the atmosphere, steady and invisible, and now you drift into the 6th square of the periodic table, oxygen. If nitrogen is the silent background, oxygen is the spark, the breath of life, the fire of forests, the slow rust creeping across iron. Oxygen lives a double life, both sustaining and undoing, both healer and thief. Take another breath now. This time, pay attention to the small fraction that makes the biggest difference. Just 1/5 of the air is oxygen, and yet without it, life as you know it would collapse. Oxygen seeps into your lungs, drifts into your blood, binds to hemoglobin, and rides through your veins. Every cell takes a sip, using it to burn sugars, to release energy, to keep you warm and alive. Oxygen is life's quiet partner, the invisible flame within, but oxygen is not only gentle. It is also restless, eager, a little greedy. Given the chance, it combines with almost anything. Leave iron in the rain, and oxygen joins it, turning shiny metal into reddish rust. Slice an apple, and oxygen darkens the fruit within minutes. Even your own body feels oxygen's impatience. Over time, its reactions contribute to aging, to the slow wear and tear of living. Oxygen sustains you, and oxygen slowly weathers you too. You drift now into a forest. Trees breathe out oxygen during the day, releasing it as they turn sunlight into sugar. The air feels crisp, alive, filled with the exhalations of leaves. It is easy to forget that much of the oxygen you breathe comes not from forests at all, but from plankton in the ocean, tiny, unseen organisms, drifting and busy, giving the world its breath. And oxygen glows in more dramatic forms as well. Feed it into fire and flames leap higher. Mix it with hydrogen and you get water in a burst of light. Freeze it into liquid oxygen, pale and blue, and it becomes rocket fuel, propelling engines toward the stars. Scientists still marvel at oxygen's duality. It is essential, yet corrosive. Nurturing, yet destructive. Life's closest friend, but also life's patient undoing. The same element that fuels your heartbeat also flakes iron bridges, fades fabrics, and chews at stone. And oxygen has other faces too. Ozone, made of 3 oxygen atoms, forms a thin shield high in the sky, protecting you from harmful ultraviolet light. Without it, the sun's rays would scorch the earth. Yet at ground level, ozone irritates lungs, sharp and harmful. Oxygen, always double-faced, wears masks of savior and trickster alike. You drift now into chemistry's history. In the 18th century, scientists called oxygen dephlogisticated air before Lavoisier gave it its modern name. He saw that burning was not the release of phlogiston, as once believed, but a union with oxygen. Fire was no longer mystical, but chemical, and perhaps the quirkiest fact is that oxygen, though so important to us, is actually toxic to many early forms of life. Billions of years ago, when cyanobacteria began releasing oxygen into the air, it was a global catastrophe. For ancient microbes used to an oxygen-free world, it was poison. Entire species vanished. For us, it became the breath of life. So rest in this thought. Oxygen is not one thing but 2, maybe more. It is the inhale that sustains you, and the rust that ages your world. It is the flame that warms and the wear that erodes. A friend and a thief, a savior and a saboteur, always waiting for the next bond, the next breath, the next chance to react. Hydrogen gave us beginnings, helium gave us laughter, lithium gave us calm, carbon gave us masks, nitrogen gave us balance. Now oxygen gives us paradox, the double life of an element that both saves and steals. Oxygen fades softly into the forest air, both friend and thief, and now you drift into the 10th square of the periodic table, neon. If oxygen is lively and restless, neon is aloof, a noble gas, untouchable, unbothered, floating at the edges of chemistry. Yet when coaxed, it reveals a secret, a glow so bright it can light the night. Picture a city street at dusk. Signs flicker to life, tubes filled with neon gas humming with electricity. They shine in deep oranges and reds, glowing steady, never flickering once lit. Neon does not burn, it shines. Electricity excites its atoms, and when they relax, they release light, pure, unmistakable. A quirk of an element otherwise so quiet. You drift now into the nature of neon. It belongs to the family of noble gases. Helium, neon, argon, krypton, xenon, radon. Each one is reluctant to bond, preferring solitude, unwilling to mix or mingle. They are the wallflowers of the periodic table, content to float without entanglement. And yet, neon has found a way to make itself famous, not by combining, but by glowing. Neon signs became symbols of modern life in the early 20th century. Paris called itself the City of Light partly because of them. Broadway, Las Vegas, Tokyo, their nights shimmered in neon's steady hues. To see neon in the dark was to feel the pulse of modernity, a soft chemical heartbeat in tubes of glass. Scientists still wonder at how something so inert can become so visible. Neon's atoms resist bonds, resist change, and yet when given just a little nudge of energy, they reveal themselves in brilliant light. Most elements show themselves in reactions, burning, fizzing, combining. Neon shows itself in stillness, in shine, and neon is not confined to signs. In laboratories, it cools delicate instruments as liquid, its low boiling point making it useful in quiet corners of science. In space, neon floats in stars, forged in nuclear furnaces and released into the cosmos. Not common, not rare, but scattered, glowing in spectral lines that astronomers use to read the story of distant suns. You drift now into neon's softer side. Imagine walking beneath a neon sign on a rainy night. The glow reflects on wet pavement, rippling with each drop. There is a kind of warmth in it, though the gas itself is cold and aloof. Neon feels like paradox made visible, untouchable, yet intimate. And perhaps its quirkiest detail is this: true neon signs only glow red-orange. The blues, greens, and purples of city lights are often from other gases or coatings, dressed up as neon but not quite the same. Neon keeps its dignity, glowing only in its own color, refusing to imitate. So rest in this thought. Neon is an element of quiet pride. It does not bond, does not bend, does not rush into reactions. It floats aloof, invisible, until it glows. And when it does, it paints the night with color, steady and unmistakable. Hydrogen gave us beginnings, helium gave us laughter, lithium gave us calm, carbon gave us masks, nitrogen gave us balance, oxygen gave us paradox. Now neon gives us glow, the quiet reminder that even the most aloof can shine, softly, in their own time. The neon glow fades into the rainy night, and now you drift toward the 11th square of the periodic table, sodium. If neon is aloof and glowing, sodium is excitable, reactive, a little too eager to join in. Left alone, it shines silvery and soft, but introduce it to water, and sodium makes quite the entrance, a fizz, a spark, sometimes even a little explosion. Picture a small chunk of sodium metal. Soft enough to cut with a knife, it gleams like polished silver. Handle it carefully, though, because the moment it meets water, it reacts furiously, dancing and spitting as hydrogen gas bubbles off. It is as if sodium cannot resist the invitation, leaping into reaction the instant it has the chance. And yet, sodium's everyday face is gentler. Pair it with chlorine, and you get sodium chloride table salt. The most ordinary, indispensable seasoning. Salt that sprinkles on your dinner, salt that preserves food, salt that seasons soups and breads. One of life's simplest comforts, born from one of chemistry's most excitable elements. You drift now into sodium's glow. In street lamps, sodium burns with a distinct yellow light, bathing roads in a golden haze. For decades, cities were lit by sodium lamps, their color as much a part of nighttime as the stars overhead. Scientists know the spectrum of sodium's light so precisely that it is used in experiments to calibrate instruments. Sodium shines as consistently as it reacts, and sodium has another quiet role hidden inside you. Every nerve impulse that sparks in your brain, every muscle that flexes in your body, depends on sodium ions moving in and out of cells. Alongside potassium, sodium creates tiny electrical signals that allow you to think, to breathe, to dream. The same excitable element that fizzes in water also carries the currents of your thoughts. Scientists still marvel at sodium's dual life. In the laboratory, it must be stored under oil, shielded from air and water, because it is simply too eager to react. In your body, it works precisely, quietly in balanced amounts, too much or too little, and the system falters. Sodium is essential, but only in moderation. You drift now into history. Salt, the humble compound of sodium, was once so precious it was used as currency. Roman soldiers were partly paid in salt, their salary from the word salarium. Entire trade routes and empires rose and fell around the control of salt. That little shaker on your table carries the echoes of centuries. And perhaps the quirkiest truth of all is how sodium transforms when paired with chlorine. Sodium alone is dangerously reactive. Chlorine alone is poisonous, sharp, and choking. Together, they form the most harmless, necessary compound, table salt. It is chemistry's odd couple, two dangerous personalities balancing each other into something safe and vital. So rest in this thought. Sodium is an element of contrast, alone, excitable, fizzing, eager to splash, but in partnership it becomes steady, nourishing, ordinary. In your nerves it sparks thought, in your kitchen it seasons meals, in the streets it glows yellow against the night. Hydrogen gave us beginnings, helium gave us laughter, lithium gave us calm, carbon gave us masks, nitrogen gave us balance, oxygen gave us paradox, neon gave us glow. Now sodium gives us contrast, the fizz of reaction and the salt of the earth, all in one. The fizz of sodium in water quiets, and now you drift into the 12th square of the periodic table, magnesium. If sodium is excitable and flashy, magnesium is brighter still, literally. It is the element of sparks and stars, burning with a white intensity that can light the night like day. Picture a strip of magnesium metal, thin and silvery. To the eye, it looks ordinary, like any other piece of metal, but touch it with a flame, and it erupts in brilliant white light, dazzling, almost too bright to watch. For centuries, that glow was used in flash photography, in flares, in fireworks. Magnesium doesn't just burn, it blazes, as though carrying a piece of a star in its atoms. And in a way, it does. Magnesium is made in stars, forged in their nuclear furnaces. When massive stars burn through their fuel, magnesium is among the elements created, scattered into the cosmos when those stars explode. The same dazzling white that lights your fireworks was once born in stellar cores. When you hold magnesium, you hold stardust. You drift now into quieter uses. Magnesium salts are essential in plants, sitting at the center of chlorophyll, the molecule that lets leaves drink sunlight. Without magnesium, photosynthesis would fail and plants could not grow. Every forest, every field, every garden owes its green to magnesium's gentle touch. In your own body, magnesium works just as quietly. It helps muscles relax, enzymes function, bones strengthen. Without it, nerves falter, hearts strain. Magnesium is sprinkled throughout you, quietly balancing the sparks of sodium and potassium, a calm companion to their excitability. Scientists still marvel at magnesium's duality. On one hand, it is explosive, a source of blinding light. On the other, it is a steady stabilizer in biology and agriculture. Firework and forest, flash and leaf, both rely on the same element. And magnesium has played a role in human history too. In the 19th century, magnesium flares lit battlefields and exploration. Photographers used powdered magnesium to capture images in dark rooms, though many an early photograph was accompanied by a startled cough from the smoke it left behind. Its brightness became a symbol of progress, of discovery, of seeing more clearly. But magnesium can be quirky too. Its flames are so intense that they cannot be extinguished easily. Water only feeds the fire, splitting into hydrogen and oxygen that burn hotter still. The only way to smother magnesium's blaze is to use special powders or let it burn itself out, a reminder that not all flames obey the same rules. You drift now into a summer night, fireworks blooming overhead. Reds and greens from strontium and barium, but the brightest whites, the stars that shimmer most intensely, come from magnesium. For a moment, it's as though the heavens themselves have descended, starlight reborn in sparks. And then you drift deeper, imagining leaves rustling in sunlight. Every photon caught by chlorophyll depends on magnesium's small, steady presence at its heart. Every loaf of bread, every apple, every breath of oxygen, all quietly linked to magnesium's role in photosynthesis. So rest in this thought: magnesium is an element of brilliance. It can dazzle as fire, yet stabilize as leaf. It burns with starlight, yet sustains with calm. It is both spark and support, both flash and foundation. Hydrogen gave us beginnings, helium gave us laughter, lithium gave us calm, carbon gave us masks, nitrogen gave us balance, oxygen gave us paradox, neon gave us glow, sodium gave us contrast. Now magnesium gives us brilliance, the sparks of fire and the quiet green of life. The sparks of magnesium fade into green leaves and white stars, and now you drift to the 31st square of the periodic table, gallium. If magnesium dazzles with brilliance, gallium charms with a trick of touch. It is the element that melts in your hand. Picture a silvery metal, shiny like aluminum, solid at room temperature. It looks sturdy enough, as though you could drop it into a drawer and forget about it. But hold it in your palm, and slowly, quietly, it begins to soften. Within minutes, the metal liquefies, slipping into a silvery puddle, shimmering like mercury yet harmless to skin. Gallium's melting point is just under 30 degrees Celsius, a few breaths warmer than the human body. It seems to giggle at the idea of solidity, giving up its shape as soon as you hold it. You drift now into the laboratory of Paul-Émile Lecoq de Boisbaudran, the French chemist who discovered gallium in 1875. He named it after Gallia, the Latin word for France, though some whisper it may also have been a sly play on his own name, Lecoq meaning the rooster. Quirky origins for a quirky element. Gallium does more than melt. Unlike many metals, it doesn't expand when it freezes, it contracts. Most substances expand as they solidify, but gallium refuses the pattern, a quiet contrarian. And unlike mercury, which stays liquid but is toxic, gallium is benign, safe enough to hold and marvel at, though messy if it drips between floorboards. Scientists still wonder at gallium's playful defiance of expectations. Solid yet not quite, metal yet soft. It even sneaks into technology. Gallium arsenide is used in semiconductors, helping power solar panels, LEDs, and high-speed electronics. A quiet reminder that gallium is not just a parlor trick, but a practical player in the modern world. You drift now into its more mischievous side. Gallium can dissolve aluminum, creeping into its grain structure and making it crumble. Engineers once joked about gallium pranks. A spoon coated with it will weaken and fall apart in tea. A spoon that melts before your eyes feels like magic, though it's simply chemistry's quiet mischief. And gallium has another charm. It looks like mercury when melted, flowing in silvery streams, but unlike mercury, it wets glass and skin. It clings, refusing to bead, spreading across surfaces as though painting them with a metallic sheen. Gallium makes puddles not of water, not of quicksilver, but of something between shiny, sticky, playful. You drift now into a thought. Imagine holding a lump of gallium in your palm, watching it liquefy, then pouring it gently into a dish. You could, with patience, cast it into a new shape, a figurine, a trinket, a tiny sculpture. And when you are done, leave it to cool, and it hardens again, ready to repeat the trick. Solid to liquid, liquid to solid, like an element's lullaby. Perhaps gallium's quirkiest role is how it reveals the hidden line between states of matter. Solid, liquid, gas, we learn these as absolutes. But gallium, with its low melting point, reminds us that the boundaries are soft, that matter slips from one state to another with just a little warmth, just a little patience. So rest in this thought. Gallium is the playful element, the one that slips through your fingers, the one that refuses to stay put. It is a puddle of silver in your hand, a reminder that even the solid things in life are not as rigid as they seem. Hydrogen gave us beginnings, helium gave us laughter, lithium gave us calm, carbon gave us masks, nitrogen gave us balance, oxygen gave us paradox, neon gave us glow, sodium gave us contrast, magnesium gave us brilliance. Now gallium gives us play, the quiet delight of watching metal melt like ice in your hand. Gallium slips from your hand in a silvery puddle, and now you drift toward a more famous liquid element, one that has fascinated and unsettled humans for centuries: mercury. If gallium is playful, mercury is mysterious, shimmering in globes that roll and scatter, beautiful but untouchable. Picture an old thermometer, a slender glass tube, a silver thread rising and falling with temperature. That shimmering column is mercury, dense and liquid, obedient to heat. For generations, it measured the weather, fevers, and furnaces, a quiet servant of science and medicine. Mercury is unique among metals. At room temperature, it refuses to solidify, flowing instead like quicksilver. Drop it on a table, and it breaks into globes that scatter, each reflecting the world in miniature. Try to catch them, and they slip away, rolling out of reach, merging back together with a satisfying shimmer. You drift now into history. Mercury was known to ancient civilizations long before modern chemistry. Alchemists saw it as magical, a symbol of transformation, the prima materia that could unite with other metals, perhaps even turn them into gold. They gave it the name quicksilver, living silver, a metal that moved like water but shone like treasure. And indeed, mercury has always had a double nature, alluring and dangerous, beautiful to the eye but toxic to the body. In old hat-making workshops, workers used mercury compounds to treat felt, a process that left many trembling and ill, mad as a hatter, the saying went. Even today, mercury spills are treated with great care, its vapors watched closely. Scientists still wonder at mercury's quirks. Why is it liquid when most metals are solid? The answer lies in relativity, the same principles that bent spacetime in Einstein's equations. Mercury's electrons move so fast that their behavior shifts, weakening bonds and preventing solid structure. Relativity makes mercury shimmer. You drift now into its modern roles. Though thermometers and barometers no longer use it, mercury still appears in certain switches, lamps, and scientific instruments. And beyond Earth in planetary form, Mercury, the planet races closest to the Sun, small, rocky, scarred with craters, a namesake sharing the same swiftness and elusiveness. But perhaps Mercury's most soothing image is this, a bowl of the liquid metal, reflecting the world above it. Unlike water, its surface curves upward, resisting the edges of glass. Dip a finger and it recoils. Mercury will not wet skin, will not cling to walls. It prefers to remain separate, whole, self-contained. There is something dreamlike in this behavior, a substance both liquid and metallic, both ancient and modern, both beautiful and unsettling. Mercury is the mirror of chemistry, reflecting but never revealing, shining but never staying still. You drift now into the thought of alchemists again, their hands hovering above bowls of quicksilver, convinced it held secrets of immortality. They were wrong about gold, but perhaps right about wonder. Few elements inspire the same fascination. So rest in this thought. Mercury is the element of mirrors, of motion, of mystery. A liquid metal, heavy yet fluid, alluring yet aloof. Gallium melts in your hand, but mercury rolls away, always just out of reach. Hydrogen gave us beginnings, helium gave us laughter, lithium gave us calm, carbon gave us masks, nitrogen gave us balance, oxygen gave us paradox, neon gave us glow, sodium gave us contrast, magnesium gave us brilliance, gallium gave us play. Now mercury gives us mystery, the shimmering liquid that rolls like silver dreams across the table of elements. The shimmering globes of mercury roll away, and now you drift into the 74th square of the periodic table. Tungsten. If mercury is liquid and elusive, tungsten is its opposite, solid, unyielding, stubborn. It is the metal that glows but refuses to melt, the quiet champion of endurance. Picture a glowing filament in an old-fashioned light bulb. A fine wire curled and heated until it shines white-hot, yet it does not melt or crumble. That is tungsten at work. With the highest melting point of all metals, more than 3,400 degrees Celsius, tungsten endures where others falter. It glows willingly, but it will not yield. You drift now into tungsten's name. From the Swedish words tungsten, meaning heavy stone, and it is indeed heavy, dense, and strong. But its symbol W comes from its German name wolfram, a nod to the mineral from which it was first isolated. The double name itself feels fitting. Tungsten is both heavy stone and glowing wolf, practical and mysterious. In your hand, a chunk of tungsten feels unusually dense, heavier than expected for its size. That density makes it useful in weights, tools, and projectiles, yet its most charming role is in lamps. For much of the 20th century, tungsten filaments lit homes across the world, glowing gently in glass bulbs, filling rooms with steady warmth. Scientists still marvel at tungsten's stubbornness. It resists heat, resists wear, resists giving in. Even when glowing white, it remains solid, refusing to surrender to flame. This makes it indispensable in furnaces, welding, and spacecraft. When engineers need something to endure, they often turn to tungsten. And yet, tungsten is not only about industry. It has a softer side, too. Alloys of tungsten are used in jewelry, rings that carry both shine and strength. In science, it anchors delicate instruments, steadying them with its weight. Tungsten is practical, yes, but also quietly elegant. You drift now into history. Alchemists once cursed wolframite, the mineral that held tungsten, because it consumed tin during smelting. They thought it a greedy wolf devouring metal, hence wolfram. Later, chemists learned to coax the element free, and its talents began to shine. And there is a quirky detail. Tungsten is the only metal robust enough to serve as the filament in old bulbs. Others melt, burn, or break, but tungsten glows for thousands of hours. The faint hum of an incandescent lamp, the warm pool of light over a desk, the glow of a bedside lamp, all carried tungsten's endurance. You drift now into a quiet room lit by such a bulb. The filament hums faintly, glowing warmly, holding steady through long hours of night. Outside, stars burn with hydrogen and helium, but inside, tungsten holds its own miniature star, stubbornly glowing without fading. So rest in this thought. Tungsten is the element of persistence. Heavy yet bright, dense yet glowing, unyielding yet useful. It is the quiet endurance of metal, the reminder that sometimes the strongest things are those that refuse to break, even under fire. Hydrogen gave us beginnings, helium gave us laughter, lithium gave us calm, carbon gave us masks, nitrogen gave us balance, oxygen gave us paradox, neon gave us glow, sodium gave us contrast, magnesium gave us brilliance, gallium gave us play, mercury gave us mystery. Now tungsten gives us endurance, the stubborn glow of a filament that refuses to melt. The stubborn glow of tungsten fades into a warm pool of lamplight, and now you drift toward an element that has always captured human imagination. Gold. If tungsten is valued for endurance, gold is treasured for beauty, the eternal shimmer, the metal that never rusts, never tarnishes, always gleams. Picture a nugget of gold in your hand, soft, heavy, shining with a warm yellow light. Unlike iron, it does not corrode. Unlike copper, it does not dull. Gold simply glows, year after year, century after century, as though time itself cannot touch it. That permanence has made it the symbol of wealth, of love, of eternity. You drift now into history. For thousands of years, humans have sought gold, panned rivers, mined mountains, sifted sands. Civilizations rose and fell on its promise. Egyptians buried their pharaohs with it. Spanish ships carried it across oceans. Even now, wedding rings and medals shimmer with the same glow that lit the eyes of ancient kings. Gold's story is not just chemical, it is cultural, woven into myth and memory. And yet, gold has quirks too. Though soft enough to dent with a fingernail, it can be beaten into sheets so thin they are transparent. A single gram of gold can stretch into kilometers of wire, hammered into leaf that gilds domes and paintings. Heavy, yet pliable, precious, yet generous with its shine. Scientists still marvel at gold's refusal to tarnish. Most metals left in the air grow dull, form oxides, flake, and fade. Gold resists, its electrons moving just so, protected by relativistic effects that shift its color into warmth. Without relativity, gold would not be golden at all. It would appear silvery, like its neighbors. Its beauty is literally written into the physics of its atoms. You drift now into its modern uses. Beyond jewelry and coins, gold sneaks into electronics. Tiny wires of it connect circuits because it does not corrode. Spacecraft carry gold films to shield against radiation. Doctors use gold in treatments, nanotechnology, and imaging. The element of kings has become the element of satellites and science. And perhaps the quirkiest truth is this: gold is rare not because Earth lacked it, but because most of it sank to the planet's core billions of years ago, too heavy to linger near the surface. The gold you hold is a survivor, delivered to the crust by meteorites long ago. Each ring, each coin, each flake of leaf is a fragment of cosmic chance, scattered across time. You drift now into a mythic vision. Ancient alchemists chased gold, dreaming of transmuting light into it, seeking perfection in their furnaces. They never succeeded, but in a way, stars did. Gold is forged in the collisions of neutron stars, born in moments of unimaginable violence, scattered as cosmic treasure. Your ring, your necklace, the gold leaf on a chapel dome, all were once forged in the fire of colliding stars. So rest in this thought: gold is more than glitter. It is permanence, softness, pliability. It is history and myth, science and starlight, desired always, enduring always, glowing always. Hydrogen gave us beginnings, helium gave us laughter, lithium gave us calm, carbon gave us masks, nitrogen gave us balance, oxygen gave us paradox, neon gave us glow, sodium gave us contrast, magnesium gave us brilliance, gallium gave us play, mercury gave us mystery, tungsten gave us endurance. Now gold gives us desire, the eternal shimmer that has captured human hearts across time. The eternal shimmer of gold fades into starlight, and now you drift toward one of the heaviest, most enigmatic elements in the table. Uranium. If gold dazzles with permanence, uranium intrigues with power, a slow fire hidden deep inside, glowing faintly for eons. Picture a chunk of uranium ore, dark and heavy, sitting quietly in the earth. To the eye, it looks unremarkable, just another rock, but inside, its atoms are restless. Uranium is radioactive, its nuclei so large and unstable that they slowly fall apart, releasing energy as they decay. It is not a quick blaze like magnesium's spark, nor a shimmering pool like mercury. Uranium burns with patience, a fire measured in half-lives, some lasting billions of years. You drift now into uranium's history. It was first identified in the late 18th century, named after the newly discovered planet Uranus. At the time, it was little more than a curiosity, used as a pigment in glass and ceramics, giving them a greenish glow. Only later did scientists discover its deeper nature, that within uranium's atoms lay vast reserves of energy, waiting to be unlocked. And uranium's quirks abound. Left on its own, it gives off heat. Deep in the earth, uranium's slow decay warms the planet's interior, driving geology, powering volcanoes, stirring continents. Without uranium and its radioactive siblings, the Earth might be cold and silent. Instead, its core churns, its crust shifts, mountains rise and oceans deepen, all fed by the quiet fire of heavy atoms. Scientists still wonder at the delicate balance uranium creates. Its isotopes decay at different rates, shaping the timeline of Earth. Uranium-lead dating allows geologists to measure the age of rocks, of mountains, even of the Earth itself. A natural clock, ticking slowly, faithfully, across billions of years, and uranium has another dramatic face. In reactors carefully arranged, its slow fission can be harnessed to boil water, turn turbines, and generate electricity. Whole cities light up from the splitting of uranium atoms, their energy transformed into steam, then motion, then glow. It is both a gift and a responsibility, immense energy packed into heavy stone. You drift now into uranium's cosmic origins. Like gold, it is born in the most violent events in the universe, the collisions of neutron stars, the explosions of supernovae. Uranium's atoms are too heavy to form in ordinary stars. They require catastrophe, then scatter through the cosmos, eventually finding their way into the Earth's crust. Every atom of uranium is a relic of stellar destruction, a fossil of the universe's most dramatic moments. And perhaps the quirkiest truth is how uranium hides in plain sight. Trace amounts are found in soil, in water, even in your own body. It is everywhere, faintly glowing, a reminder that radioactivity is not only in reactors or weapons, but woven quietly into the natural world. You drift now into a deep cave, where uranium ore glows faintly under ultraviolet light. Not blinding, not fiery, but subtle, a ghostly green, the color of hidden energy. It is not dangerous at a glance, not explosive, not immediate. It is patient, slow, steady, a fire that never rushes. So rest in this thought. Uranium is the element of endurance and power. Heavy, patient, born in cosmic collisions, glowing with the faint heat that keeps Earth alive. It is both danger and gift, both cosmic relic and earthly fuel. Hydrogen gave us beginnings, helium gave us laughter, lithium gave us calm, carbon gave us masks, nitrogen gave us balance, oxygen gave us paradox, neon gave us glow, sodium gave us contrast, magnesium gave us brilliance, gallium gave us play, mercury gave us mystery, tungsten gave us endurance, gold gave us desire. Now uranium gives us patience, the slow fire that warms planets and measures time itself. The slow fire of uranium fades into the deep earth, and now you drift to the end of our quirky journey through the periodic table. From hydrogen's light beginning to uranium's heavy patience, you have wandered among elements that sparkle, fizz, glow, melt, and endure. And now it is time to rest among them, to see the table not as a chart of facts, but as a lullaby of matter itself. Picture the periodic table not as rows and columns, but as a quiet garden at night. Each element is a lantern, glowing softly in its own color, humming with its own story. Hydrogen flickers like a candle at the entrance. Helium floats away, drifting like a balloon. Lithium hums gently, steady and calm. Carbon shapeshifts like a masked dancer. Nitrogen blankets the air like a quilt. Oxygen glows, friend and thief alike. Neon shines aloofly, painting the dark with color. Sodium fizzes with sudden sparks, magnesium blazes like fireworks, gallium melts playfully in your hand. Mercury rolls away, mysterious, mirrored. Tungsten glows stubbornly, refusing to melt. Gold gleams with eternal shimmer. Uranium smolders with patient fire, and in the middle of this glowing garden you lie still, surrounded by the very atoms that shape your body, your blanket, your breath. You are not separate from them, you are built of them. The carbon in your skin was once in a star. The calcium in your bones was once in the Earth's crust. The oxygen in your lungs was breathed out by leaves and plankton. You are part of the periodic table, stitched from its quirks, carried by its patterns. Scientists still marvel at how something as simple as protons, neutrons, and electrons can weave such variety. The table is just a map, and yet within it are diamonds and rust, laughter and flame, nerves and stars. It is both a catalog and a poem, both a chart and a lullaby. You drift now through the table as though floating above it. Rows stretch out like rivers, columns like families. The noble gases stand quietly at the edge, aloof but glowing. The alkali metals fizz and spark, eager to react. The transition metals shimmer with color, from copper's orange to cobalt's blue. Each element whispers its own story, and together they sing the chorus of matter. And perhaps the quirkiest truth of all is that the table is unfinished. New elements, heavy and unstable, have been added in recent years, living for seconds before vanishing. The garden still grows, its outer edges filled with fleeting blooms. Chemistry is not done writing its poem, so rest in this thought. You are not lying in a bed, not drifting only in sleep, but floating among the elements themselves. They cradle you, surround you, hold you. The hydrogen in your water, the oxygen in your breath, the carbon in your heart, all of it is the table's quiet embrace. Hydrogen gave us beginnings, helium gave us laughter, lithium gave us calm, carbon gave us masks, nitrogen gave us balance, oxygen gave us paradox, neon gave us glow, sodium gave us contrast, magnesium gave us brilliance, gallium gave us play, mercury gave us mystery, tungsten gave us endurance, gold gave us desire, uranium gave us patience. And altogether they give you rest. The table hums softly, not as numbers, not as symbols, but as matter itself. And tonight it is your lullaby, and now the periodic table itself grows quiet. The garden of elements fades into starlight, each lantern dimming until only a soft glow remains. You have walked among the quirky metals, the glowing gases, the restless builders, and the patient giants, and what lingers now is not their chemistry, but their calm. Take a deep breath in, hold it gently, let it go. The air you just breathed carried nitrogen, oxygen, a trace of argon, all steady companions. The water in your body holds hydrogen, oxygen, and a touch of minerals. The very warmth of your skin is energy moving, atoms vibrating, the laws of chemistry humming softly. You are part of the table, stitched from its elements, resting in its order. Let your muscles soften, like gallium melting in a warm hand. Let your thoughts scatter, like mercury globes rolling away across a smooth surface. Let your breath steady, like the glow of tungsten in a quiet lamp. The elements do not hurry. They do not fret, they simply are. Carbon takes its time to build diamonds. Gold waits for ages untarnished. Uranium ticks its slow clock for billions of years. You too can rest without hurry. The table holds you. The atoms cradle you. The night surrounds you with its chemistry. You are safe. You are warm. You are at peace. Close your eyes a little heavier now. Let go of the chart, the names, the numbers. The story is finished. The poem is complete. All that remains is balance, breath, and sleep. All is calm. All is quiet. All is rest.